Hey, is this thing on? Hello, everyone, and welcome. Hey, Dexter Starboard and C. Grover and Mr. Certainly over in the Discord chat, and hey, everyone over on YouTube. Hey, John O. Nice to see you all. Yeah, hey, I'm back. I flew all the way to the East Coast and back here, and boy, are my arms tired. But seriously, folks, it's great to be back. Great to have you all here. I'm excited about our new product pick of the week this week. Hey, Doctor, nice to see you. I'm going to have a sip of delicious ice water. Boy, that's good. Refreshing. So let's do this, shall we? We're back. Thanks for letting me get away for a week. It was nice to have a little bit of a vacation. And now we're going to dive into it. So, how does this thing work? If I remember correctly, what I'm going to do is let you know that if you want to watch the show from inside the product page, you're going to get 50% off discount during the live stream. All you have to do is head over here to this QR code or to this URL right here, and you will jump on over to the product page. You can watch this show from inside the product page, and that's pretty darn cool, but you can get that 50% off on this product this week. It's a discount that's only good during the live stream, so be sure if you're interested in it to load up. I think you can get a maximum of 10 of them during this special pricing. No reseller prices or no reseller sales, just for the people who want this product. But before we go any further, why don't we find out a little bit about the product from Lady Ada. So I'm going to have Lady Ada take it away.
NeoKey 1x4 QT. So, how to explain it? Basically, you want to add mechanical keys to your project. You don't want a ton. You maybe only want 4 key switches. You want NeoPixels with them, but you don't want to do all of the wiring for it. You want to have it over I2C, and maybe also want to chain it with more of them, right? You can actually connect multiple of these. So this is a way of very quickly adding 4 mechanical keys with NeoPixels to any board. It has a C-style microcontroller on the underside, which does the I2C to NeoPixel and key switch conversion. I've got my QT Py here, so it's just something that has an I2C connection. And this is running Arduino, but it works also with CircuitPython just fine, or Python, so you can use it with a Raspberry Pi, or what have you. And each key has a NeoPixel underneath, and this demo, just when you press it, it does a little NeoPixel color swirl. So that's the demo, and you can have multiple keys pressed at a time. They have Kale sockets, so these are socketed, so you can use any Cherry MX compatible key. This is, I think, Cherry Black or Kale Black, I don't remember. And then, of course, you put your favorite keycaps. Maybe it's a little kitten keycap, or maybe it's these translucent ones, so you get the glow through. And you basically have a very easy way to add 4 keycaps, key switches to your project. And then the I2C comes in. This is the chip that handles all of the key presses and the NeoPixel stuff. And there's address jumpers here, so you can close these, which allow you to connect multiple boards to one I2C port. So you can have up to 16 of these on one I2C bus. So if you're not enough to make a full 108 key keyboard, but you're making like a macro pad, right? And you just want to really quickly get a bunch of keys together without much soldering. You just plug in your favorite mechanical key, and you have plenty of mounting hole options. So you've got 4 mounting holes on the corner. You can also plug into a breadboard if you don't want to use these cables for easy perf boarding. I just think it's like a fun way to get mechanical keys into your project without any key matrix handling, without NeoPixel handling. It's all done for you.
Hey, wrong button. Yes, so the important question that Doctor asked in the chat was, did Lady Ada grow an extra hand in that video? I think that was PT's hand visible there, but I thought the exact same thing. How about that? So I'm going to go grab one of these myself, and then we'll talk about this. Am I really muted? That was weird. Little thingy looked like it was going. All right, let's try that again. The product pick of the week this week is the NeoKey 1x4 Cutie I2C mechanical key switch board. It has 4 sockets for placing your mechanical key switches, and it has 4 underlit NeoPixels. So you can plug this into any board that has I2C, and particularly convenient when you have STEMMA QT connectors. And you can plug in your key switches to the board. So there you can see I've got a set of 4 key switches on there, a couple of red ones linear, a couple of black ones, a little tougher to push, and some different keycaps on there. So what I want to do is jump to the overhead here, and we can take a look at this in action. So here you can see I've got a little cutie pie, and I've plugged in one set of our NeoKey 1x4 to there. But since we have address jumpers for I2C there, I can, in this case, change the I2C address for a second one and plug that in as well. So I'm going to go ahead and just plug that in using a little STEMMA QT cable. And then I'll reset the board there, and those should restart. And then we'll be able to use all 8 of these keys. So here you can see I'm not actually doing anything other than changing NeoPixel colors when I press, but you could set these up, of course, as HID, as general I/O, as MIDI. There's a lot of uses for these. And in this case, I have, I think, a maximum of maybe it's 8 of these that we can plug in, or 16. I think Lady Ada said that. So you could get a pretty big array of these. You can mount them to something using the little mounting holes on there. You can also put these into a perf board or a breadboard using the header cable or header pins if you want to solder those in. Now to show something a little more fleshed out here, I've got a little demo board that I've put together. And so what I have here are, this is the NeoKey 1x4 Cutie plugged in over I2C to a feather board. And then I also have some of our little rotary breakouts here, little rotary Trinky breakouts. And so what you can see here is I have some keycaps that are re-legendable, which means the little plastic tops pop off and you can print something out and put a label or a sticker under there. So I've set this up to be a little keyboard shortcut board for use inside of Photoshop. So as you can see here, I'm going to go ahead and switch over to Photoshop, which some things were acting really slow when I was trying to screen capture it and show it to you. So we'll see if that still works. So right now you can see I have a little eyedropper tool picked there. And if I press this first button, I switch back over to a brush, switch to the eyedropper. This is the eraser tool, and here is a gradient tool. So if I go to the brush here, I've also set up my little rotary encoder to be a brush size. Normally in Photoshop you can pick that with a slider, but you got to go click on it, or you can use the bracket keys to go bigger and smaller. But now I have a little rotary encoder, and I can also change the softness and hardness of that brush. So I can go in here and paint a little bit, and then let's say I want to switch to blue. I'm going to hit my eyedropper, grab blue, switch over here, and start painting in. Oh, did I get blue? Doesn't look like I did. Oh, that's weird. What's happening with the eyedropper? Hey, eyedropper. Am I on? Oh, I'm on an invisible layer. How about that? Let's turn that back on. Okay. That's better. I was in a funny mode. Okay, so here you can see I can paint in blue. I can hit my eyedropper, switch over to this pink, switch to a different brush, maybe change the size of that, paint in there a little bit, and we can go and erase. So I'll switch over to that eraser with this little shortcut, and then we can start erasing. If I hide this layer here, you'll see for real erasing, straight up erasing. So that's one use of this, is just as a little shortcut keyboard, and I'll show you how that works. It's actually really straightforward. In whatever app you're using, in this case Photoshop, there will usually be some keyboard shortcuts. In this case, B goes to the brush, I goes to the eyedropper tool, E goes to the eraser, and so on. So if we look at the code here inside of CircuitPython, let me switch, put on my glasses here so you can see. In this case, I'll go over the more standard case in a second, but I'll just show you in this case, the key things being, I'm actually using the debouncer in this case, and when I look at what happens during the main loop of the program, I have things like if key 0 rose, which is this is a pull down, so it rises when we press it. When that voltage rises, we print to the serial brush, just so I know that I did the right thing while I'm debugging. And then I'm changing the NeoPixel color. I'm setting all of them to white except for the current one, which I'm latching to a color that's unique for that button. And then I'm sending this key code. This is using our USB HID key code commands to send a key code B. And we have I set up for eyedropper, E for eraser, G for gradient, and so on. Now, let's look at the sort of standard example. So I'm going to bring this back. Unlike some of the typical ways that you'll use buttons plugged into GPIO, this is using our Seesaw over I2C. So a lot of the heavy lifting is done for you by the Seesaw library. So here you can see in CircuitPython what's going on. I import the board for pin definitions. I import this Adafruit NeoKey library, and from that I'm grabbing the 1x4, so we have room to add other specific types of boards. And I'm importing that object as NeoKey 1x4. We set up the I2C bus, and then since I'm using two of these boards, I'll actually create two different NeoKey objects. I just called them NeoKey and NeoKey 2. And those have the same command, which uses the NeoKey 1x4, and it specifies this is on the I2C bus and the address. So one of them is at address 30, the other's at address 31 because I soldered that jumper under there. And then the main loop of this is actually pretty simple. Let me go ahead and open up a serial port so we can see what's going on. I'm going to unplug the other keyboard so we hopefully grab the correct one. Okay, so what happens now is when I press a key, the Seesaw library, this is the only command you need to know if you want to check one of these keys. It's just NeoKey and the value of it at the address that it is. So NeoKey 0, 1, 2, and 3, or NeoKey 2, 0, 1, 2, and 3. Those are the buttons, and those values are true when they get pressed, otherwise they're false. So when I press this first button, it says button A was pressed. It changes my NeoKey color to red. And then when I release it, it changes the NeoKey color back to blue. And then I have those set up to do a few different colors and names when I press them. And then my second row here is just called button A2, B2, C2, D2. And you can press these all at the same time if you want. It'll register them all. It's a little hard to read that. But you can see here A2 is pressed, as is button D. And those will just scroll by there. You can use this with a debouncer or other more sophisticated methods if you want, but just to get you started, it's really straightforward to just simply ask using Seesaw and this NeoKey library. You can just check for the value of a button to see if it's pressed or if it's not pressed. Let's see, let me check and see if there's any questions over in Discord here. Oh yeah, you know what? Let me show the page here, which I forgot to show you. So here is the page for this board. You can see we've got some nice pictures there of the backside, front side of the board. You can see this uses these nice little Kale sockets, which allow you to just press and remove, no soldering required. In fact, you can use this entire board without any soldering. And if you're using something like this Cutie Pie here, since these both have the Stemma QT cable, you can simply plug them in with one of the different Stemma QT wires that we have. These are quick compatible wires, and they come in a few different lengths. So this is ready to go with zero soldering, which is terrific. You can of course solder. We have all of those same I2C pins broken out here on the board, and so depending on your needs, you've got a bunch of different options for how to set this up. The key switches for this are any Cherry MX compatibles, so that's Gateron, Kale, Cherry MX. We have a bunch of different Kale box switches available on the site here too, in the clicky, tactile, and a couple of linear types, but you may have others that you like. And as well, we have a bunch of different keycaps. So since we've got the NeoPixel under there shining through, you probably want to try something that's either translucent or windowed or has a silicone kitty paw like that one there. Super cute. And we sell a few of those as well on the Adafruit store. If I refresh this site right now, you should see, hey, we have 55 of them in stock and they're half price, so $4.98. You can bring one home today, or 10 if you want. If my math serves me right, that'll be $49.80. And let's see, the library for using this is on GitHub. I don't believe we have this in the bundle yet, in the CircuitPython bundle. We're working on, there'll be a guide coming out that'll point you at all these things, but if you get one now and you want to get started, you'll go to GitHub and just search in the Adafruit GitHub for NeoKey. And there you can see Adafruit _CircuitPython _NeoKey, that's where the library is. And clicking on here, you can download the whole thing. So you just go to this green code button, download zip, then you'll have everything you need. And what you'll place in your library folder of your CircuitPython capable microcontroller, like the little cutie pie I have here, is this Adafruit NeoKey folder that contains the library you need. And in the future, we may add more boards to this. Right now, the NeoKey 1x4 is the only one in there. And you've got a folder of the example code. So if you go to the examples and try this code here, it's really similar to what I did with this basic example, other than changing the LED behavior a little bit in the colors and then adding the second set. So we could continue to add these on and get a pretty interesting board. You can also create some interesting shapes, right? If you've got some unusual needs for your board, you can lay them out in ways other than just sort of a simple grid or something that you could place on a perf board. You could also turn these at diagonals. You could create a letter Z. I don't know why, but you can. Or a V or an A. So let's see. The comment here over in Discord, Doctor says, I can't afford switches for all my MX compatible things. Yeah, when you get a lot of these going, you start to pile up on the switches and the keycaps. Question, can you get the value of the keys as a number? So key 0 is 1, key 2 is 2, and so on. So if you pressed 1 and 4, the sum would be 9, and you know 2 keys are down at the same time. Yes, you could code that for sure. You could set up some conditionals. You could have variables or lists that are adjusted depending on which keys are currently pressed. So there's probably a few different ways that you could do that. But yeah, it knows that multiples are down, and you can query that. You can also use things like the debouncer library, which can go and check those as well without the need for pauses and things to avoid the key repeats. Or you can use little simple state variables that you flip a state of something when it's pressed. So for sure you can do some neat sophisticated stuff so that you can do big chorded macros and change the behavior based on modifier keys. So you could have one of these act as a shift key or a control key, command, that sort of thing for sure. Aza's built to code asks, can you string up? You can string up 16. Neat. Does Adafruit sell a larger 4x3 format version? It is coming. It's on the way. We have a 4x3 macro pad in the works. If you check the Desk of Lady Ada videos on YouTube, you'll see some progress being made on that over the past few weeks, and including some really exciting work on the keypad library that will read matrix keypads and vector keypads using diode matrix layouts really quickly. It's native C code that's running in the library, even though you're using CircuitPython, so it's lickety split. I think it pulls the whole thing in 3 milliseconds, nanoseconds, picoseconds, something small. I can't remember what, but it's fast. Was the thing, and I think that's about it. Yeah. So thank you for coming and stopping by, asking your questions. Let me go to the full view of that for a second there. This is what you'll get right here with the NeoKey 1x4 Qt I2C mechanical key switch breakout key strip. It's not exactly its official name, but that's going to do it. So let's put this up on the big board. That's our product pick of the week. It is the 1x4 NeoKey. The product pick of the week is the NeoKey 1x4 Qt I2C mechanical key switch breakout with NeoPixels and socketed key switches. So I'll go ahead and place that on my new product pick of the week board of goodness, and that's going to do it. So thanks everyone for stopping by. And if you have other questions, put them in the Discord chat, put them over in the YouTube chat, and I will see you next time. Be sure to stop by tomorrow for lots of different live streams on Adafruit, including Show and Tell and Ask an Engineer and the 3D Hangouts in the morning with the Ruiz brothers. And I'll be doing my workshop show on Thursday, so come on by for that. I believe Scott is still off, so no Friday deep dive with Scott, but that'll be returning pretty soon. I think maybe the following week. So that's going to do it for today. I'm JP, and I will see you next time. Bye-bye.